So in our last video, we talked about why and how we use units, and we talked about some examples of some units we use, like distance and time, and it was all pretty obvious. And this is going to be almost as obvious, but it's going to get a little bit more convoluted and a little bit more, I don't want to say difficult, so let's say a little less simple. And you'll see what I'm talking about as we get further along in the video. So let's start simple, though. Let's start with combined units of, like, let's say speed. Well, what is speed? Well, speed is just, it's how fast something moves. It's how fast something moves. Or another way to say it is its distance over time. So another way to say it is distance over time. So we already looked at a couple in the last video of this. We looked at, like, well, we used miles per hour, or another way to write that would be, let's say, miles per hour. Is it written out as a math way? Another one is, well, meters per second. Another one is obviously feet per second. And these should all be incredibly obvious, both in what these units are and what they mean, unless, you know, you're like that woman in that one YouTube video where she didn't know what miles per hour meant. But let's go a little bit more difficult than speed, and that's acceleration. Let's choose a different color here. Let's do blue. Acceleration. Well, what is acceleration? Well, if you think about it, acceleration is just how fast your speed changes. So how fast your speed changes. So in other words, it's speed changing, so change in speed over a period of time. Or another way to think of it is just speed over time. So what is speed? Well, we just said, well, that's what, let's go ahead and draw an arrow, is meters per second over time over second. Well, that's just like saying meters over second twice. So meters times second. Or another way to write that is just meters per second squared. And then in the US system, of course, we do feet. That T looks suspiciously like an F, but feet per second squared. But essentially, these are the units for acceleration. So let's go a little bit more relevant to our class, and that's, well, work. Well, what is work? Well, work is measured as what we call force times distance. So force, and I wanted to make that look a little bit nicer, but force times distance. And it's as simple as it looks. If we said Anderson, me, I'm Mr. Anderson. Anderson moves 5 pounds, 2 feet. Well, that's 5 times 2. Force, 5 pounds, times distance, 2 feet. So that's 5 times 2 is 10. And then pounds times feet is, well, we call that foot-pounds. That's the unit, foot-pounds. Just like we call this meters per second, we just call this foot-pounds. And in fact, in the U.S. system, in the U.S., the unit we use for work is always foot-pounds. And the metric system, or as we call the SI for International System of Measurements, the metric system, we use newtons. Newtons for the force and meters for the distance. But another way to say this is joules. So joules is the unit for work in the metric system, and foot-pounds is the unit for work in the U.S. system. You could also say newton meters, and we'll talk about more of that later. Hopefully by the end of this video and the next video, you'll understand why we call it joules. But let's go ahead and break down the units in work. So let's say work equals force times distance. And so we don't really need to break down what distance means, because we all know, I mean, it's meters or feet or whatever. So meters or feet. Let's not do that. That's going to look confusing. Or feet. We know this. We know distance. But force gets a little bit more complicated, and let's simplify it a little bit. So in the U.S. system, actually, let's go ahead and, since we already did SI first, let's say keep it consistent. In the SI system, Force is, as we just said, is newtons. And in the U.S. system, force, as we just said, is pounds. And then we'll call this SI as well, just to make it clear, and this is obviously US. But you might be asking yourself, or at least you should be asking yourself, what is a newton and what is a pound? Essentially, what is a force? Well, like work, how it has its own formula, force also has its own formula, and it's mass times acceleration. So this formula is what we're using this to break down what pounds and newtons are. So, well, what is mass? Let's start with that. Well, in the SI system, you should know by now what mass is, but that's kilograms. And in the US system, you might not know this one. This is kind of weird. It's kind of a really weird name for mass, but it's measured in slugs. Fun fact, Mr. Anderson is about 5.4 slugs. And if you'd like to know how many slugs you are, you have to Google it. But all mass is just how much space you take up. And so in the US system, we measure that in slugs. I take up 5.4 slugs of space. And then, of course, we know what acceleration is. We already set it up here. It's either meters per second squared, or feet per second squared. And this is, of course, the SI system, and then this is the US system. And then that's not even going into what we've already talked about, how to break down acceleration into speed and distance, speed and time. And then we can change speed into distance and time. So the point I'm trying to drive home here is that when we use combined units, we use things like newtons instead of, well, if you look what a newton equals, so let's write that out, 1 newton. Or better yet, let's go write out 1 pound. Let's say 1 pound. Just because that'll be more fun because we can use slugs. Well, 1 pound, if you look, well, pound is force, and force is mass times acceleration, so that's mass is slugs. So it's 1 slug, the same thing, or let's slow down. 1 pound is the same as saying 1 slug times feet per second squared. And so hopefully it's kind of obvious why we combine units and then rename them. Because 1 pound is a lot easier to say in conversation. And that's our breakdown of combined units.